We're going to continue with discrete random variables. What we're going to do is we're going to look at some word problems. We're going to look specifically at a definition, and that's the expected value. And remember, the expected value is the mean and the cost of the game. So a fair game is whenever expected value or the mean amount of money that you're supposed to get from the game and the cost of the game are the same, then that means that it's a fair game. If the expected value is more than the cost of the game, that's a game worth playing. It means you're going to more likely win than lose. If the cost of the game is greater than the expected value, then that's probably a game that you don't want to play. It means you're more likely to lose. So what we're going to be doing is we're going to be looking at two different games and seeing if it's a fair game, meaning that the expected value is equal to the cost of the game. So for the first one, what we're going to do is we're going to set up a table, and our x values are our possibilities, and the probabilities are, or the p-value is the probability of that specific value. It says a person rolls doubles when she tosses two dice. She wins $6. The cost to play the game is $1. What is the expected value for the game? Is the game fair? So there's two options. Either the person wins $6 or they win nothing. Those are the only two possibilities. Now we're going to look at how does a person win $6? Well, they roll two dice. So if the person's rolling two dice, then we have two probabilities, and the person's rolling doubles. Now let's just look at one possibility. That would be a 6 and a 6. So in order to get a 6, that would be 1 6. And in order to get another 6, that would be 1 6. Now, it's not just rolling a 6 and a 6. They could be rolling a 1 and a 1, or a 2 and a 2, 3 and a 3, 4 and a 4, or a 5 and a 5. So there's 6 possibilities that the person could roll doubles. So if we multiply this out, that would be 6 out of 36, or 1 6. So the probability of winning $6 is 1 6. Now, because this is a discrete random table, that means that if the probability of winning is 1 6, that means the probability of losing would be 5 6, because these have to add up to 1. So that gives us our table. Now what we're going to do is we're going to find our expected value. So the expected value is the same thing as the mean, which means that we take the $6 and we times it by the probability. We add that to the 0, we times it by the probability. Now looking at this, I know that this gives me 1 and this gives me 0. So that means the expected value is $1. So the question is the game fair? And the answer is yes, because the expected value is equal to the cost of the game. Let's look at our second our second game. This time what we have is a bag. The bag contains $1 bills, $5 bills, $10 bills, and $100 bills. A person is charged $20 for selecting one bill. So let's look at all of our options. A person grabs a bill out of the bag. Either the bill is a 1, a 5, a 10, or a $100 bill. Now we're going to find the probability of each one. This is a little bit easier than the last one because we just have to look at all the different possible bills. We have 15 plus 2 plus 2 plus 1. That would be a total of 20. So for each one of these, there are 20 possibilities. Now looking at the $1 bill, there's 15. Looking at the $5 bill, there's 2. $10 bill, there's 2. And for the $100 bill, there is 1. So what we're going to do is we're going to find the expected value. So the expected value for this game is equal to the mean, and that would be 1 times 15 over 20 plus 5 over 2 over 20 plus 10 2 over 20 plus 100 times 1 over 20. This one I'm going to pull out my calculator and figure it out. Some of you are probably able to do it by hand, and that would be perfect. I'm going to turn it into a decimal so that I actually understand the dollars and cents. And I figured out that it's $7.25. That right there is my expected value, or my mean. That means on average, if somebody were to play this game lots of times, they would get about $7.25 per game. So the question is the game fair? And a lot of you have probably already guessed. No, the game is not fair. Because the cost is greater than the expected value. This is definitely a game that is not worth